Good morning. My name is Jose Viscarando. I am the Systems and Avionics Lead for Team Reacher, and in this presentation I'll be going over the validation and verification testing of the Ironbird and the system assembly test. The following presentation consists of a personnel overview, then followed by the Ironbird test, the assembly test, and then concluding with our final thoughts. Here are the 6 members that make up Team Reacher, including myself, like I said before, Jose Viscarando. The Ironbird test consists of a simulated aircraft structure, and its primary purpose is to test the functionality of the different avionics and mechanical components of the Hero 1 aircraft. Some of our driving requirements to conduct this test are that we are to design Hero 1 so it is a stall or VTOL aircraft, and we're also designing it to have an imaging system that's able to broadcast live video. Some of the subsystems that were tested as part of this test include the flight controller, the receiver, motors, GPS, the video system, and the servos that actuate all the flight control surfaces. So on this slide you can see the actual Ironbird rig itself. The body of the Ironbird here was designed in SolidWorks and 3D printed out of PLA, which is a thermoplastic. After it was printed, the primary avionics components that were to be tested were installed. And in this image, as you can see, we have our flight controller and our power distribution board right here in the center. We have 2 servos primarily for our tilt systems, one here and then one here in the rear. We have our ESCs, which are these blue electrical circuits here, which control the output to our motors, which you can see here. And we've also installed some auxiliary sensors, like right here. That is the GPS unit, and this unit right here with this these long tubes, that's our airspeed sensor right there. And we also have right here on the bottom, this right here is our receiver system to allow us to actually control the aircraft. For safety reasons, the propellers were kept off during testing. The Ironbird rig was secured to the bench, and the power supply system was limited to 2 amps. These are the results for our Ironbird test and the different levels of success. We've shown that we can reach level 1, 2, and 3 for these tests. And as you can see here in the images below, this is a test of the tilt rotor system. I'll go ahead and play that real quick. So as you can see in that test, we verified that the transmitter and the receiver are communicating wirelessly. We showed that the aircraft, when the mode is changed from vertical flight to tilt rotor flight, we're able to see that the actual servos cause the rotors to actually tilt forward and then tilt back into the vertical position. So we concluded that that was a successful test of those 2 systems with that video. And in this video here, this is the motor function test, and what we're doing is, again, we're making sure that the throttle input of the pilot correctly registers into the flight controller, and then we get the correct response in our motor. And I'll go ahead and play that video so you can see those results. So that video did or that test did verify that our motors were properly mapped to the correct throttle inputs, and that the pilot was actually getting the the result that he was looking for when he put his input. The next test I'll be going over is the assembly test. And the purpose of the assembly test is to verify that the Hero 1 aircraft can be rapidly assembled by two crew members. And we also checked that it can fit within the design requirements criteria, which is that the Hero 1 should fit in a 5x3x2 volume. Some of the things that some of the subsystems that were also tested as part of this test were the wings, the left and right wing assembly, the tail assembly, the motors, and the propellers, as you can see here in this image. The assembly test was conducted in EB3 in the hallway of the senior design lab. Some of the tools we used to conduct this test were a 9/16 socket with a 3/8 drive wrench, an Allen key set. We used masking tape to measure out the dimensions for the simulated box, and we also used a stopwatch to record our time. And the procedure we took to actually conduct this test is that we started the stopwatch when in the beginning of the test, and the first thing we did was we removed the tail and wing assemblies from the storage box, or in this case the simulated storage box. We connected the left and right wing assemblies together to the center spar. Then we installed the wings to the fuselage using the 8 9/16 hex head bolts. We then installed the tail spars into their correct place on the wings and secured those with 4 bolts. After that, we moved on to installing the right motor to the motor spar and the propellers to the corresponding motors. And for safety, we had a fire extinguisher present. The results for our assembly test, we were actually able to exceed a level 3 success, but that was only after several attempts. We noticed a couple things that made the assembly difficult when we first assembled it. Some of the issues we were running into was the cables for the servos were a bit too long, and the bolts to secure the wing itself were really time consuming. So we're thinking about possibly making some changes to that in the future. But overall, after conducting a couple runs of the test, we became pretty proficient at it, and we exceeded the level 3 requirements like I mentioned before, and we were actually able to assemble it in under 5 minutes. And that's this video right here. I'll go ahead and play it. This video is actually sped up 3 times, so it should be quick. There we are installing the wing and the motors. Like I said, those bolts are really time consuming. So in the future, we might think of a better way to kind of attach those wing bolts. And just to note, the battery is connected in the aircraft, and the receiver is also connected, so that the aircraft is pretty much ready to fly once we install the rotors. And that was a successful demonstration of that test there. In conclusion, the successful completion of the iron bird test gave us confidence that our electrical components were correctly mapped and programmed and were functioning as intended. And the successful completion of the assembly test shed some light on a couple key areas where we could improve, but ultimately showed that we're capable of assembling the aircraft with 2 crew members in under 10 minutes. And I think completing both these tests will ensure that Hero 1 will satisfy the customer's requirements. From Team Reacher, thank you for taking the time to listen to our presentation.